In this module of Chapter 2, Module 2.11, I will examine the interconnectedness of the life table parameters. Here are the 5 main life table parameters. There are 4 important connections or relationship among these parameters that merit comment. First, although both LX and PX are survival concepts, LX is survival to age X of the original cohort, but PX is the probability of survival from one age to the next. Second, PX and QX are complements that sum to 1. If PX is the probability of surviving from X to X plus 1, then the value of QX must be PX's complement, or 1 minus PX. Thus, if the probability of surviving from X to X plus 1 is 90%, then the probability of dying equals 10%. Thus, to know the value of one of these parameters is also to know the value of the other. Third, QX and DX are both parameters concerned with death. However, as I noted in the last module, QX is the probability of dying in a single age interval given individuals are alive at the start. In contrast, DX is the probability of a newborn individual dying in the interval X to X plus 1. Fourth, expectation of life is a mean that refers to the average number of days or years an individual age X has remaining. Here I animate graphs of 4 main life table parameters to show how each relates to the other. Note in this first animation how each changes with age relative to the other. Survival and expectation of life both decreasing, mortality increasing in DX, first increasing then decreasing. Now note QX alone, very low initially, followed by ever increasing higher rates at older ages. Now consider QX as a driver of survival. Since mortality is low for the first 60 years, survival is high, with over 90% remaining alive after the first 60 years. However, as mortality continues to increase, survival in the next 30 years declines from 90% to less than 20%, and then finally to near zero at 100 years. Finally, consider the DX distribution as a consequence of QX. First, the early deaths show up at DX, although not noticeable on the QX schedule shown here, that is, infant deaths. Because of the low mortality to age 60, there are relatively few deaths overall on the DX schedule up to and through that age. Then the 30-year window of low survival from 60 to 90 that was observed in the LX schedule is manifested as a 30-year window of high cohort deaths as seen in the DX graph. In other words, nearly 90% of all deaths in a cohort occur after age 60 with a peak of around 85 years. That is the mode. The carry-away messages: life table parameters are inextricably linked to the actuarial data from which they were all derived. However, they each reveal different information about and unique perspectives on these data.